In this lecture, we're going to see some tricks we can use to access characters in our stdstring one by one. If you look here, this is our representation of stdstring. It is really a wrapper on top of a character array inside, and it's going to do all the dirty things, keeping track of the boundaries of the array or adding in the null character and things like that. There are a few ways you can access data character by character, and we're going to see those ways. But it is also possible to get a pointer to the contained array inside your stdstring. And we have two methods, cstring or c_str and data. And we're going to see how these things work. But before we do that, let's see how we can get access to these characters one by one. If we want to loop through our stdstring and access each of these guys using a loop, we will need some way to get the size of that string. And stdstring has another behavior which is called size, which is going to give us how many characters we have in there without counting the null terminator. So we can use this in a loop like this. So here we have our string. We're going to loop through it. We're going to say for size, and we're going to loop until we hit str size. You know, however many characters we have in there, we are going to increment and jump inside and use the angle bracket notation. And this is really cool. You see that the syntax we were using on arrays also works on stdstrings. And if you do that, you're going to have your string printed out. We're going to try this out in a minute when we hit Visual Studio Code. But before we do that, we have a few more things we need to see first. We can also loop through a range-based for loop, and this is now a piece of cake for you. You have seen a range-based for loop like 1,000 times. So we're going to say for char value and inside our string, and we're going to be printing out each character in the string at each iteration, and this is going to work. We can also use the at behavior in our stdstring type. The way we do that, we say str at, and we say the index for which we want to get the character. This is really a variant of the angle brackets notation that stdstring provides. And this can be convenient in some situations. So you're going to choose whatever helps you better. We can also go through these two syntaxes to modify character data in our string. For example, we can say str1 at index 0 and assign a b to it, and we assign a character. Or we can do str1 at 1 and specify the index in this parenthesis and say what we want assigned in the string at that index, and this is going to work. You're going to see how this works out when we hit Visual Studio Code in a minute. There are also a few behaviors we can use to get the front and back characters. This is going to give us copies if you use them as you see here. For example, here we have our string, which is the Phoenix King, and here we have variable, and it is of char type, and we're going to call str2 front. This is going to give us the front character, which is going to be the F here. We can also use the back behavior and get the back character, which is going to be this K here. If we print them out, we're going to see them printed down. But if we do things like this, we can go through these front char and back char variables and modify the underlying string here, because these are just going to be copies. If we want to affect this guy, we will need to go through references. And we can do that like this. For example, we can say char front char ref like this, and this is going to be a reference. You see that we used the ampersand symbol here, and we can do the same for the back character. Now we're going to have references to the actual characters in our string. And remember that references are really true aliases, and we can use them to modify the original data as if we were going through the original variable name. And if we change the back character here, we're going to be really changing the back character in our string, and you're going to see that this is actually the case. We can also modify our data directly through the calls to front and back like this, and this works because these functions actually return references to the front and back character. So this is basically the same thing here. We are just doing it directly. If you use const references to grab your data from the calls to front and back, you can't go through your references to modify the data. If you do that, you're going to get an error because these are const references. You can't go through them to modify the data that these two guys reference. I hope you understand this. And we have learned about references in the last chapter. Okay, These are ways you can access individual characters in a string. But sometimes you want to get a pointer to the real character that std_string is really wrapping around. And we have two ways to do that. One is through the c_str behavior. And here you see our string here, which is the Phoenix King. And we can get access to a pointer to the underlying character array like this. We set up a const char pointer. We call it wrapped c_string. And we say str2 and call c_str behavior here. If we do this, we're going to get our pointer in this variable here, and we can use it to manipulate our string. For example, we can print it out, but please note that this behavior of this function returns a const pointer. So you can't go through that to modify the underlying data. If you do that, you may get a compiler error, or you might even get something really bad. So don't do it. The other way we can do this is go through the data method. And this is the reference to the documentation for this behavior or this function. You can go there and learn all you can about this. But here we're just going to use it. We have a string 2, which is hello world. We're going to set up a character pointer and assign that to the result of the call to the data behavior. And if we have this char pointer, we can either go through it to print the data or to modify the data. And you're going to see that this is going to work once we hit Visual Studio Code and try this out. We are actually going to go in Visual Studio Code and show you these things in action. Okay, here we are in our working directory. The current project is accessing characters in std_string. We are going to grab our template files pretty quick, and we're going to put them in place and open this in Visual Studio Code. And we are going to include our std_string library. That's the first thing we need to do here. We are going to go down here and put in our code. Here we set up a std_string. It has hello there inside, and we can get its size through the size behavior. Another thing we can do now that we have the size is use the size to loop around. For example, we can say for size t, we're going to put in our iterator. We are going to loop until we exhaust the size of the array, and we're going to keep incrementing and printing each element at the iteration using angle brackets like this. And this is a syntax that is going to work. So I don't think I need to explain this very much because we have seen for loops a lot of times. We have used this syntax on arrays. I am just going to try and run this and show you what we get when we print this out. We're going to build with GCC like we always do, and we are going to clear and run Rooster. We're going to see that our size is 11 if we count these guys 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So these are the characters without counting the null terminator. So you have to know this. This is the number of characters that you have in here. Now that we have the size, we're going to loop for 11 times because we have 11 characters, and we're going to print each one, and we're going to use the index method using angle brackets notation here to target each character in our string here. And if we do that, we're going to get hello there printed out, and you see that we are accessing each character and printing it out. We are going to comment this out because we have more things I want you to see. So we're going to put this in a block comment like this. We can also go through a range-based for loop and print each character in our string here. So we have the same string here, and we are using a range-based for loop. Down here, you see that we say for char value in our string, and we're going to be printing each character inside. If we build and run this, let's do that. We're going to build with GCC, and we are going to clear and run. We're going to get the same thing here, hello there. We are just using a range-based for loop. So this is something you can do if it is what makes sense for your project. We can also use the @ syntax and target each character that we want to print. And the way we do that is through code like this. We're going to put that in here, and we are basically going to loop a couple of times. We're going to loop until we exhaust the size of our string. And we're going to be using the @ behavior on our string here to print each character. It is just an alternative way to do what we have done with the angle brackets notation here. We just have to specify our index in parentheses like this. And if we print it out, we're going to get the same thing printed out. So let's build with GCC. And we're going to clear and run this, we're going to say hello there. That's exactly what we expect here. We can comment this out again. The next thing we're going to see is that we can go through the @ syntax and the angle bracket syntax and modify characters inside our string here. Here we have a simple example. str1 is going to contain hello there. We're going to change the character at index 0 to a B, and we're going to change the character at index 1 to an A. And if we print this out, we should see below there. Okay, so we can go through these syntaxes and modify data inside our string if that's what we want in our application here. So we are going to build with GCC like we always do. Let's do that. And let's close this thing because it's taking up space that we could use for other things. And we're going to clear and run rooster. And you're going to see that we say below there, we have successfully modified these characters here. We're going to comment this out as well. And we're going to look at the front and back functions of the stdstring type. We are going to go down here and put in our code, and we are going to be using the front and back functions to get the front and back characters from this string here, which says the Phoenix King. So the front character is going to be the T here, the back character is going to be the G here, and that's what we're going to see when we print these things out. So let's build with GCC and see if this is actually the case. And the build is good, so we can clear and run rooster. And you see that this is what we have. Front is T, back is G. Now, if you try and use these characters to try and modify the string in here, it's going to look like it works. But if you run the application, that's not going to work. So let's try and change front character to something else. Let's use R, for example, and take back character and change that to let's use a D. Why not? Okay, now that we have attempted to modify the front and back characters through our variables here, let's try and print out the string here. So we're going to say stdcout pretty fast. And if we build, we're going to build with GCC. The build is going to go through. But if we run this, we're going to see that our string hasn't changed. And you see that the string still says the Phoenix King. So why is it the case? We are modifying front car and back car, but the changes are not being reflected in our string here. Try to think about this. What is happening here? Well, what we have here, front car and back car, are just copies. Okay, because these are row variables. So these guys are going to be copies. And if we modify a copy, this is not going to modify the original thing. If you want to affect the original thing, you want to make these guys references, because we've seen that references can be used to actually affect the original thing. So if we change these guys to be references with a syntax like this, you already know about references, by the way. So if you do something like this, this is not going to affect the original string, because front car and back car are respectively references to the first character or the front character and the back character in this string here. Let's try and build again to actually show you this in action. We are going to clear and run rooster. Now you see that the first character is an R and the last character is a D. If you don't want these references to be used to modify the original string, you can make them const. We already know something like this. And if we do this, you're going to see that the attempt to modify our characters are going to fail, because this is something read-only now. You're going to see that's what we're going to get in Visual Studio Code here. And if we try to build, we're going to get a similar error that we are trying to modify something that is read-only. So we shouldn't do that. Let's take out these const keywords, because I just wanted you to see this, but I feel like we should allow people to modify this thing through these references. And we're going to comment this back out. Let's build so that we get rid of these errors. We're going to use GCC. The build is going to be good, and we're going to clear, and we're going to comment this out. The next thing we're going to look at is that we can get access to the underlying character array using the string behavior on our string here. Here we have another string. It is called str2 and the content is the Phoenix key. If we want to get access to the underlying character array, we can say str2 and call the c_str function on this type, and we're going to return a pointer to this. And how do I know this? From the documentation, you can go there and see this information. We're going to get a pointer, but the pointer is going to be const, and we shouldn't really go through it to try and modify the data in the string. For now, we're going to try and print this out. You notice that we are trying to print the string here. It is going to be null terminated because stdstring is smart enough to give us something that is ready for use. So we are going to build this with GCC, as we always do. And we're going to clear, the build is good, and run rooster. You're going to see that we're going to print this guy, but we are going through our const char pointer here. So if we try and go through this pointer and modify the data in here, for example, say wrapped cstr and say 0, for example, and try to assign something, let's use a e here. If we do this, we're going to get a compiler error because this is a const char pointer. It is a pointer to const char, and we can't really go through it to modify what is pointed to. This is something you don't want to do, and that's what you get from this function here, c_str. So you shouldn't really try and modify the underlying string through this return pointer. That's not the intent of this function. Okay, if you want to modify it, you should use the data method, and we're going to look at that next. So this is going to give you a compiler error. Let's say that. We are going to go down here and put in the code to play with our data function. And we have a string that is saying hello world like this, and we call the data function on our string type, and that's going to give us a pointer, but the returned pointer is not going to be a const pointer. It's not going to be a pointer to const. So we can go through that and modify our data. So we print the original value here, and we go in and use the data pointer here to modify the first character to say B. And if we print this after modification, we're going to get the modified version through the data pointer. But if we also print the string, we're going to see that the string has been modified. And this proves that we can go through the data pointer to really modify the data that the string here is working on. We are going to build this with GCC so that we can try this out. The build is going to be good. You see that the compiler is not stopping us from using this pointer to modify stuff. And we are going to run this. Let's clear and run rooster. The original value is hello world, but you see that if we go through the data pointer, we're going to get hello world. And if we go through the string, we're going to get hello world. We have successfully modified our data. And this is really all we set out to do in this lecture. I realized this lecture also turned out to be really long, but I had to show you these examples because this is the best way to learn, in my opinion. You're going to try these things out, run little snippets of code, and try to get them to do things. That's how you really get an understanding of these things. The goal here was to be able to access characters in our strings and do all kinds of crazy things with them. And we have seen that we can use the angle brackets notation here to go in. We can also use the @ syntax like we are doing here. And we have seen that we can also go through the data and the cstr functions to get access to the underlying character array. c_str is going to prevent you from modifying the data through the returned pointer, and we can modify the underlying data through the pointer returned by the data function here. And this is really all we had to see in this lecture. We are going to stop here in this one. In the next one, we're going to learn about how we can get size and capacity information from an std string. Go ahead and finish up here and meet me there.